Good morning, students. Today I am starting next lesson, coordination compound. It is lesson number 5. In the coordination compound, you are going to learn about coordination compound. There is a complex compound. So before going to the complex compound, you should know what is called addition compound. Addition compound is formed by the combination of two simple salts. You know already what is called simple salts. Simple salt contains one cation and one anion. For example, sodium chloride, it contains Na plus and Cl minus. But what is called addition compound? Addition compound will have more than one cation and more than one anion is called addition compound. That is two simple salts combined to form addition compound. This addition compound is two types. This addition compound is two types. One is double salt, another one is coordination compound. One is a double salt, another one is a coordination compound. First, what is called a double salt and what is the difference between double salt and coordination compound? Difference between double salt and coordination compound I explain with one example. The double salt is, example of double salt is more salt. More salt is an example of double salt, or potassium is an example of double salt. We studied already potassium sulfate and aluminum sulfate combined to form potassium. Today I take example more salt as an example of double salt. More salt is formed by ferrous sulfate and ammonium sulfate .6H2O. This is example of double salt. Ferrous sulfate and ammonium sulfate are combined in a particular proportion and forms a double salt. So in this double salt, you have two cations. Ferrous is a cation, ammonium is a cation, and one anion is the sulfate is an anion in double salt. But whereas in the coordination compound example is K4 FeCN6. It is formed by KCN and ferrous cyanide, potassium cyanide and ferrous cyanide to give this salt. This is called potassium ferrocyanide. Potassium ferrocyanide. For more salt is an example for double salt, and coordination compound example is potassium ferrocyanide. Potassium ferrocyanide, this complex is formed by one Lewis acid. Another one is Lewis base. For first difference, you can take this one is the first difference. Double salt is formed by the combination of two simple salts in a particular proportion. Coordination compound is formed by the combination of Lewis acid and Lewis base. Then second difference is when the double salt dissolves in water, it dissociates into its constituent ions. It dissociates into Fe2 plus, SO4 minus, and NH4 plus, then 6H2O. So it dissociates like this. Double salt, when it dissolves in water, it dissociates into its constituent ions. But whereas in coordination compound, when it dissolves in water, it dissociates into one cation and one anion. One cation and one anion. Here there is a ferrous, there is a cyanide. This ferrous and cyanide will not dissociate, will not decompose. So double salt dissociate into its constituent ions, whereas the coordination compound dissociate into one cation and one anion. This is a complex. This complex will not dissociate. So ferrous ion will not dissociate, cyanide also will not dissociate. Then here the third point is, here these ions retains its property. These ions retains its property, but here ions do not retain its property. So these are the differences between double salt and coordination compound. If you want fourth point, you can take fourth point example. Example for double salt is a more salt. Example for potassium coordination compound is potassium ferrocyanide. So these are the differences between double salt and coordination compound. I am coming to second question. Second question is Werner theory. This is another important question. Explain Werner theory. Werner theory. Werner is the first scientist to discover coordination compound. He discovered first compound, coordination compound is COCl3.6NH3. This is a compound discovered by Werner. This is the first coordination compound discovered by Werner. So Werner is the father of coordination compound. Okay. Now I am coming to the topic Werner theory. Werner explains in the coordination compound there is a Lewis acid and there is a Lewis base. So here is the Lewis acid. CO is the Lewis acid. CO is the Lewis acid. This Lewis acid is called central metal ion. Central metal ion. Then this Cl is this NH3 is called ligand. This NH3 is called ligand. So CO is a central metal ion, NH3 is a ligand. CO, central metal ion, is acting as a Lewis acid, ligand is acting as a Lewis base. So these two combine to form a coordination compound. So Werner explains based on the valencies of central metal ion. You know what is called valency? Valency is a combining capacity. For example, in water molecule, formula is H2O. So oxygen combined with 2 hydrogen. So the valency of oxygen is 2. So valency is a combining capacity. So each central metal ion will have valencies. The first point he explained each metal ion have 2 different valencies. 2 different valencies named, one is a primary valency, another one is secondary valency. Primary valency, another one is secondary valency. This is the first point. Each central metal ion will have 2 different valencies. So CO combined with Cl3 and NH3. Here NH3 is acting as a secondary valency. Cl is acting as a primary valency. So now you have to explain what is called primary valency, what is a secondary valency. If you explain this, you can write Werner theory. Primary valency, secondary valency. Okay. Second point, primary valency is also called as ionizable valency. Primary valency is called ionizable valency. So the primary valency will dissociate. It forms ions. Secondary valency is called non-ionizable valency. So secondary valency cannot be separated. Non-ionizable valency. So secondary valency will combine with the central metal ion directly. Then next point is primary valency corresponds to oxidation number of central metal ion. Primary valency corresponds to oxidation state, otherwise oxidation number. You can write oxidation state also. Oxidation state of central metal ion. Suppose I write the complex CO, Cl3, 6H2O. So this is the primary valency. This oxidation state is -1. So 3 chlorine is -3. So central metal ion oxidation state is +3. So this +3 depends on this Cl. So this is a primary valency. So primary valency corresponds to oxidation state of central metal ion. But here secondary valency corresponds to coordination number of central metal ion. Coordination number of central metal ion. What is called the coordination number? Number of bond developed between central metal ion and ligand is called coordination number. So here CO, Cl3, 6NH3, this is called ligand. There are 6 ligands, so the coordination number is 6. So this is a secondary valency, Cl is a primary valency. Above secondary valency corresponds to coordination number of central metal ion. Then third point is, this primary valency always satisfies by negative ion, but the secondary valencies always satisfies by negative ion or neutral molecule called ligands. So ligands are secondary valencies. So what is called ligands? You can write this answer. The substance which satisfies secondary valency is called ligands. So that is negative ion or neutral molecule which satisfies the secondary valency is called ligands. Then fourth point is, around the central metal ion there will be 2 spheres will be acting around the central metal ion. One is this one very close to the central metal ion is secondary valency. This is primary valency. So this you write by 1. So since primary valency is away from the central metal ion, so these will be ionizable. These will be removed from the central metal ion, but the secondary valencies are close to the central metal ion, so these cannot be removed. So there are 2 spheres around the central metal ion. Inner sphere is acting as a secondary valency, outer sphere is acting as a primary valency. This you write as a 4th point. I will give the answer in the I will send the answers also. Then 5th point, primary valencies are non-directional. Non-directional means it explains the shape of the complex. Secondary valencies are directional because the direction depends on the coordination number. So it depends on the coordination number. If the coordination number is 6, the shape is octahedral. So here the complex is given, this complex, the coordination number is 6, so the shape is octahedral. If the coordination number is 4, the shape is tetrahedral. So secondary valencies are directional, primary valencies are non-directional. This is the Werner theory. You study clearly the Werner theory, and it's a very important question. It will be asked in 5 mark. So today I have given 2 answers. One is the difference between double salt and coordination compound. Another one is the Werner theory, postulates of Werner theory. I will send the notes. So study these 2 answers. Then remaining answers I will send you tomorrow. Thank you.